Hello and welcome. I'm Bill Wake. We're here working on a program to compare the similarity of tunes, and lately we've been working on this report that's going to tell us the average melody. Let's see. I think we can skip forward a few pages. Remind you what that looks like. Okay, so on the left, degrees of the scale, the first, second, third, fourth pitch up. Across the top is the measure number. Well, it's the measure number and beat within the measure. 1 1 2 1 2 1 3 1 C is common 4. And then in the contents of the cells, how many songs put that note at that position? And we take the mode and we can statistical mode. We can shape out what's the most common tune in a sense. Okay. We have, let's see, we're to the point where we've got a report object that doesn't do much. It just shoves the metadata information through, like most reports. We haven't iterated across all the notes to capture the data, so we got to do that and then actually write the report. So let's do that. Okay. Now, what I remember from vaguely yesterday, we started writing a test. I feel like I don't have a great way to create new songs yet, but we got all the mechanism, and the report is after all the processing and parsing and everything has been done. So we should be able to use the ABC format and do it that way. File input tests. Well, it's not so helpful. Manual input. Yeah, we're mostly checking for errors. Parser. But maybe we can do it anyway. Let's see. File input tests. Okay. Source.input. Oh, we're using the stage. Let's see what stage does. Let's go to create. Well, create gives us our packet, so that's not bad. Okay, so we set the input and call create, and we get a packet. I think we can live with that. Maybe manual input source would be a better one to go to, though. Okay, create. It takes the parser, does fine tunes, and returns a packet. Well, we could also do that. Okay, maybe that's enough for us. All right. And, well, let's just make a method. Create tunes. Yields a tunes. Parser fine tunes input. Okay. Let's return that. Actually, I just want to give it the notes. Let's give it notes of type string. And I'm going to default the rest. So, excuse me, let input equal. Oh, well, let's do that like this. And why those don't line up, but they show 4 spaces, I don't know. Okay. We want to say X some number, key title is title, key is G, and then the notes. Okay, so that's a proper ABC format. I also want to make, I'd like to go with quarter notes just so I'm not having to type so much to get through a measure. Okay. And, okay, so, so I guess what we want to do is, I guess we want average tune reports. Okay. He calls populate. I mean, that's really what I want to see first. Maybe this should be on scale degree table. It's hard to know because the scale degree table doesn't know anything about tunes right now, but it's the thing that needs to have all the statistics. So it seems like maybe it could know that. Let's do that. Scale degree table. So we're going to move this method over. Make it public. And then he doesn't need the table because that's his argument. Okay, and now this is something I can test directly. It's not private on that. And then this one is going to delegate. Oops. Average tune report is going to delegate. Okay. And scale degree test. And what is this? Yeah, that's not relevant. Okay. I guess this. Let's put this on tunes. We'll make a helper for our test. I don't know, a lot of setup here, isn't there? Okay, but domain. Let's make new file. Not a test. Tunes plus, I don't know, what do we call that? Maybe create. We certainly could call it create. Okay. Extension on tunes. Create. Maybe this is static. Would that be all right? It seems like more of ABC parser, doesn't it? I'm kind of trying to pay attention to where things belong, and this thing, the code is all about the parser and nothing about the tunes. The tunes is the result of the parser, so we'll do it that way. Okay, so now I think we're ready to do this. Well, I think what we want to do is create a tune. We may have to adjust that thing. I don't know. Let's start with one tune. So we're going to capture statistics. I don't know what we want to call it. Counts for one tune. Okay, and we'll say let tune let tunes equal ABC parser dot create, and then we'll give it some notes, which it can be really anything. If I do ABCD bar DEFG, okay, I should get eight notes marked for two measures. Okay, so we got two measures there. Should find them both. And all right, let's do another CPAD. Okay, so now three measures. Okay, and if we call table and then well, what do we want to check? Let's start with the table size. Table dot row headers row count. No. We had some maximum. Oh, did we not publish that? Highest measure, highest note. I think we want to publish those. Okay. And highest measure should be measure 2, 0, 1, 2. And the highest note should be 3. And that's let's start there. Should get nothing back, -1s, which I don't think is quite right, but I feel like I want counts, not indexes. Okay. Let's see what we do with those. Zero highest measure. Okay. Doing measure plus 1. I'm going to back up a little bit. Let's comment this out for a moment. Because I want to make this 3 and 4. I want them to be 1 based. But we know they're -1, so that's not going to work. All right. So scale degree. All right. So everywhere that's doing whatever it is, I want to make it 1 higher. So I can make this 0 and this 0. Okay. Now I need to add 1 all over the place for them. So this should be 1. Well, let's see what we get. I feel like I'm doing something off here now, but measure and note number should be, lose the 1 here. Okay, this should be equal 0. And this is maybe an or. Well, let's leave it what it is. Okay. I think we got to add the 1 here. Let's see if these tests pass. Right, this should be an or. If there are no measures or no notes, I don't know how one could happen without the other, but in any case. Huh, what do I know? Okay, what's highest measure? Probably going to be 0, right? Huh. So how did it get here then? Oh, this is should be greater, not equals. Jeez. And this should be and. Okay, I'll get there. Okay, if the highest measure is greater than 0 and the height note number is greater than 0, then we can proceed. Otherwise, we want to return. All right, I think that's more like it. So whatever bug I had yesterday, I slept like 18 hours of the last 24, and I am clearly not quite up to snuff mentally. All right, but that's good. So we change highest measure number and highest note number to be 1 based. Okay. Come on. All right. And now our tests, we can go back to this. It's still going to fail, but that's okay. Okay, and we're going to get 0s now instead of 1s, presumably. Or, yeah, instead of whatever we want. All right. Now, the reason this is not doing is because populate is totally empty. Okay, and so what we need to do is, given a bunch of tunes, walk through them. Oh, and it's a sequence. Okay, so we can do that easily. All right. For tune in tunes. Okay, now we've got a tune. It should be type tune. Yep. Okay. And then we want to walk through the measures of that tune. We need a count though. Okay. Maybe we should do measure number in 0 dot dot. I don't know. Let's let measure number equals 0 for measure in tune.measures. Okay, so run through the tunes, run through the measure number. Now we need to, well, what's in the measure? So for symbol in measure dot symbols. Okay, there we go. All right, so now we have the measure number. We need a symbol number, I guess. Look. Okay. And then at the end of tune.measures, we need to bump that measure number. And similarly here. And then there should be var, as should this. Okay. All right, now what we're going to do with symbol, well, we're going to populate it. Increment, well, we need to get to the scale degree. We got the measure number and the note number. Okay. Increment, oh, we need the scale degree. Equals, well, this is interesting. I don't remember scale degree enough. Let's see. Okay, we can well, that's the scale degree. I forget, where do we calculate that? Oh, is it on note? Note.scale degree. Okay. Right. Well, this is symbol dot note, symbol dot scale, no, symbols possibly multiple things. Okay, I just want to get through it. Okay, switch symbol. Note, let note. Default. Can I do that? Oh, I think I say break. Okay. If it's a note, we want. Well, I'm working on it. Okay. If it's a note, we want to say let scale degree equal note dot scale degree. I'm gonna say note dot key. That is probably not right in the long run. Okay, and given that we have the scale degree, we're going to put that. We're going to use the increment. So increment the scale degree, the measure, and the note number. tell you what. Let's make our test a little more thorough. Let's say, let's look in the table. Assert equal table sub. Wait, a subscript somewhere. Scale degree, measure, note number. Okay. Scale degree. Key of G, A is 2. Our octave is 4. It's just a default thing. And measure 0, note 0 should be equal to 1. Okay. Okay. The fourth scale degree, well, let's take D and key of G. It's the fifth scale degree. I don't know. We're going to get some mess up on the. Well, let's just take the second one there. B is the third scale degree, GAB. Okay. And that's measure 0, note 1 should be 1. And then let's go for the last one. I'm not going to check them all. Okay, so the last one, scale degree, D in the key. I think it's going to be scale degree 5 octave 3, measure 2, note 3. Okay, and then let's test one negative thing. Octave. Let's test its neighbor, I guess. If you were to look over at 5.3, measure number 2. Okay, if we take 4.3. Okay, so a different scale degree. Since we only have one tune, you can't have two in the same column. Okay, so 2, 3, same measure, different scale degree should be 0. Okay. Good. All right, now this. Yeah, so we want to increment scale degree and measure number. And symbol number. I should need a label on that, I think. Okay. So we're walking all this stuff. Anytime we get a note, we're going to increment that location. Okay. And then, that should get us through it all. Okay. Kind of a big method. But let's see if it passes the test. That's the real check. No. Okay, what am I doing wrong? 0 is not 1. Wait, didn't I have 4? Did I delete the one I care about? 0 is not 1. Two, 3. Okay, scale degree 2 is, or 0, 0 is A. 2, 3 is D. Scale degree, that should be 4. Oops. Octave 3, yes. Scale degree 4, octave 3 should not be there. That is a 0. Okay. let's stop here and look at our table. I don't know if we have a print for it. It's so big. We'll just stop and look. He may be unreadable. Oh, that's not bad. Okay, okay, good. Good, good, good. Not saying it's great, but we can 0. Okay, yeah, so we only use certain numbers. These are the positions, scale degrees. So 3 values. A. Well, I really had to. That's probably B is twice. A, B, C, D, C, B, A, D, D. D is in there 3 times. Okay, yeah, that's probably D, maybe? 3 values, 3 values, 2 values, 2 values, 2 values, 3 values, 1 value, 4 values. I don't know. All right, let's put a debug print on there. Okay. Scale degree table. Custom debug string convertible. Debug description, yes. Okay. What are we gonna do? Wow, getting the scale degree back out is something. Well, let's go highest measure. Well, I'm thinking. Okay, we got something to get from the, where's the row info? Scale degree rows. We have degree to index, but it would be nice to get index to degree. Okay. I don't know. This is, I don't know if you'd say this is index to degree. All right, let's pause things and index and return scale degree. Pause our other test and let's go back and augment this one. Okay, we can skip. All right, where's his test? Okay. All right, let's check that first row. So if you recall our rows, it's in scale degree table, I think. No, it must be in here. Okay, there they are. We have this one for things above. Well, this is really octave 4, and this is 5, and this is 6 and higher. But we really kind of consider them 0. I don't know. It's kind of weird. I don't know if we're on the right thing there. Okay, but if we get a greater, let's just return let's see, let the index will be 0. So cell degree rows, and if we say rows dot index to degree of 0, then we want to make sure actual should be scale degree, and I don't know this one. Let's say 1 and then make up a super high octave number. It can't happen, but just to give us something to know it works. And then I'm going to go ahead and add a couple other tests. Let's do the corresponding one for low. Do we have access to these row header names? Headers. Okay, we got count. So count minus 1. Rows at index degree. Let's take rows dot count minus 1, and let's make this one minus 99. Oops. I don't know. We'll see. Okay, and then, well, we can get those two. Let's look at those two first. Scale degree rows has no member index to degree. Well, it doesn't compile, but okay. Editor placeholder. Okay. Try again. Okay, good. All right, so we'll peel that off first. If index is 0, return scale degree 1 octave 99. That's a little weird. Return this otherwise. Okay. And this test should pass. This test should fail. Actual is rows. It should be S. Oh. What have we got here? Oh. Huh. All right. So 0 is what we get back. Okay. Yeah, that's what we're getting. And we expected this 99 thing. Let's make sure. Let's do that too. Well, it's really count minus 1. Return this. I don't know. We should. Using a sentinel value like this is a little crappy. But I don't want to put another type of wrapper around our scale degrees, like, oh, it's either a low or a high or an invalid. Okay. All right, this one should pass. Okay, now let's do the main ones. And let's just do a check, make a check function. Check, Whoops. Let's check degree index. We're going to need some functions, some arguments. All right, so what I want to do is well, let's do I don't know if I can say check degree index. We're going to give it, this is index 2 degrees, so we're going to give it some indexes. Well, I don't know if I can do it this way. 1 should be scale degree, degree 7, octave 5. Okay, it's a little arbitrary, I know, but that's the 7 plus. Okay, and so he needs an index, and he needs a expected, and this is just an int. Okay, and so he's going to do this stuff. Index degree, this is index. Octave. I guess this is just expected. Okay. Don't need this stuff. Okay, so degree 1 is 7. This is so arbitrary, I don't know. So there's 2, 3, 4, 5, 6, 7. Seven should be 1. Notice they add up to 8. That's reassuring. Okay. Now let's do the octave 4s, 3s. Okay, so index, well, this should be 8 and 15 plus 6, 14. 15 and 21. Okay. That's a good test, I think. Milovan, welcome. All right, so we're kind of in the middle of a mess. What I'm trying to do is create a report that shows kind of like what's the most common notes in a tune, and to do that, we had a test that kind of walked through all the notes and everything. We got an error and we couldn't see what was going on in the table we're trying to build it from, and so we're going to create a debug string that shows us the contents of that table to kind of make it easier to understand. And to do that, we're adding in this index to degree function that converts. Basically, we have a bunch of labels, and we got to convert them back to the index that corresponds to them. All right, and see, this should be failing every time. Yeah, so we just returned to 0, and it didn't quite work. Okay, so down here, we're not returning that. So I have to... All right. If index is greater than or equal to 1 and less than or equal to 7, all right, we're going to do something. Else if index greater than or equal to 8 and less than 14. I don't know. Else if index greater than or equal to 15 and less than 21. Something. I think this one will fall through here. Okay, let's just make this an else. Okay. I don't know. This is... It's so arbitrary. I just don't know. Okay, but anyway. Well, we're going to return... scale degree 8 minus index octave 5. I mean, this is so arbitrary. T minus index octave 4. Maybe, I don't know. Maybe we should just build another table. 22 minus index octave 3. Okay. And then this supposedly can't happen, but let's just make that do that. Yeah, I mean, I think I might just put it in a table in a minute here. Let's get this working and work on it. What? Okay, let's just run these tests. I'm not sure what that's doing. Okay, that's together. I don't know how I'm on my to-do. Compute the scale degree for each node. We kind of stacked up a couple other tasks. We want to write a debug description for scale degree table. And we are compute index to degree for scaled degree rows. Okay, and I think, well, we've done the version of that, but I want to improve it. Okay, so let's, I don't know, I'm stacking these up funny, but we'll come back to that one. Let's get this on today's accomplishments. Yeah, I'd never manage otherwise. Okay. And it's kind of a backward, the first one is a stack and the rest of them are a list, usually. Actually, I put this one backwards, but that's kind of the way I'm working, is like the task I'm working on is on top, kind of a stack of these, and then from here down is just more ideas that could be in that sort of order. I don't know why I got inconsistent. Probably because I moved these down. A debug description. Okay, so yeah, we're coming back to this one. And why this test, how it even got here. Okay, let's run this test again. I'm not sure what the deal is, why that would blow up. Maybe it just doesn't like this breakpoint. I mean, it may not get the right answer, but okay. 0 failures. Good. Okay. Yeah. It's odd. Okay. Let's uncomment this. So the problem we had was this, we can't make sense of it, because actually I do want a breakpoint here. Okay, so if we look at table, it's just too much. I've got these indexes and values, and it's like there's some empty and some not, and what's going on. So I think we want to make this table print something that looks a little more consistent, I guess. More useful to us. Okay. So what I think I got to do, okay, let's do return, and this, let's just say scale degree table, and then what can we pull out of it? Well, we know measure and note number. Highest measure, and then highest note number. What are you doing to me here? Okay. Now, I think we're going to have to go through them. Okay, so it's a 3D table, so it's huge because we're counting scale degrees times measures times notes, and that's these 3 levels. So I guess we're going to go through, and I don't know, I feel like I'm writing my report here. Maybe that's enough info for now. It doesn't give us enough to do our thing, but let's see. Can I make sense of this? The problem is this set of indexes wraps down to this one. So 12 is 3. Okay, in the key of G, that's B. Okay, so the B, let's go to our test. So the B is in note number 1. Okay, that's good. And in measure 2, this one, it's in note number 1. That's correct. Okay, and then this is the A. it occurs twice. Measure 0, note 0. That looks okay. Maybe my indexing is off. I mean, these are looking plausible. Note 3 is A. Yep. Okay. A, B, C, O. G4. A, B are higher. C, D are lower. Okay, so this is 14. Oh, okay. Well, I'm not feeling super supported by having to walk through this thing like this. Crazy. 14 is 1, which is key of G is A. Okay, so next one is 15 is 2, which is the G. Okay, measure 1, note 3. Yeah, that seems okay. Then the F, measure 1, note 2. Okay, these seem okay. Maybe my understanding of scale degree is wrong. All right, what's the test here? Scale degree. Scale degree 2 is A. Octave 4, 0, 0 should be 1. Okay, let's just step over that. Okay, did that 0 is not equal to 1. Okay. I don't know where. Yeah, okay. Oh, I didn't say measure, note number. Wait a minute. Didn't like it either way. Declared here. Missing arguments for parameters 2 and 3. Okay. 0, 0, 0. I don't know. It's like I'm seeing it in. I'm seeing it in the table where I would expect to see it. Okay, so 12. Go back here is scale degree 3, GAB. That's the B. Okay, and then 13 is A. Okay, so 13, 0, 0. Okay, so I almost wonder if my scale degrees I'm screwed up on. Okay. Scale degree rows. Dot. Oh, it is. They are zero based. Oh my goodness. Okay. Well, that's more sensible. Octave 5 should be octave 1, 0, -1. That much I can get. All right. And then my test needs to look in the right place for these. Okay, so this is octave 0 minus 1 minus 1. Okay. Ugh. I'm just going to hope for the best. Okay. Huh. All right. So scale degree table. Basically, this is the big deal. It populates the table from the tunes. Okay. And I guess what we haven't proved. Well, this, I think I need to allow for multiple tunes. So I'm going to allow multiple strings here. Let's just do, well, let's do the lowercase version. So this is the higher octave. Okay. And then that, and then this method needs to take an array of strings. Okay. And I think we want to accumulate this. So let's, I think this is a map, right? So if we take the notes map, map, and we'll just take this. And this can be $0. Okay, we don't need this anymore. Okay, so what we're doing is we're mapping each string into its own tune body in this weird format. We've got ABC format, and we need to do a dot joined. Okay. All right. Let's run this again. Yeah, that's not, shouldn't break the old. Oh, yeah, no, this is actually wrong, isn't it? Oh, something's wrong. Highest note number, that is not right. 8. I don't even know how that would happen. Something's not being reset between tunes. Well, no, it's probably not being reset in here. Note number, symbol number, right. No, wait a minute. So I guess I need to reset symbol number. I don't know. I'm resetting it here, or I'm adjusting it up. The next measure, I should start it back to 0. So what I'm seeing is when I put two tunes in, it says my maximum note number is 8. That it really should be 4, because the biggest measure I've got is 4 notes. So I'm guessing it counts the next tune. Yeah, I don't know. I guess I want to see where this gets updated. Or maybe I can just print these. That might just be the easiest. Note number. Okay. And let's run just this one test. Okay, got a bunch coming out. Zero, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, 4, 5, 6, 7. Huh. Okay, so the 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3, that's our first tune. And then our second tune is somehow picking up note number 4. Oh, and his measure number is wrong too. He should be back on measure 0 for that tune. All right. Let's go look at this again. That should give us 2 tunes. We'll break here. I don't know. This is really 2. Okay, so I want to stop and make sure we're putting in the right string. I don't think it really ran. Thank you. All right, let's see, input. X1 title, we should see 2 line feeds. We are only seeing 1. Okay, so it treated it all as the same tune, basically. Let's join new line. I don't know why, because it looks to me like that looks like a totally blank line. I would have thought that would get in there as another new line. 1 here, 1 here, but all right, let's do it again. New line, new line. Okay, that should be working better. And continue. All right, let's put a little more on this test. So much. Okay, let's just check something on the this note. Let's take the last one. So this is D is the 5th note of the scale in key of G. 5, the octave. It's really 0. So uppercase is the main octave, lowercase is the octave above. So G here goes G, A, B, and then C, D, E, F, G, and so on. So that note should be 5 scale degree octave 0, and its position is measure 0, note 3, and we expect that to be a 1. Maybe I should let's change this one so they both have that. We can get it more than a 1 in some case. Okay, scale degree 2, 0, octave 0, 0. This should now be a 2. All right. Okay, and let's clean out some stuff. Delete. Print. That, okay. Whoops, 6 failures. Index to degree. Oh, hey, I didn't change these. Okay, this should be 1, 1, 0, 0, minus 1, minus 1. Okay. Alrighty. So we made scale degree populate from the list of tunes. All right. So where that puts us then, we're kind of back in our report now. Well, we did that. Improve, I'll save this one. I don't know, somewhere down here. All right. Compute the scale degree for each note in each measure. We've done that. And now we want to work on the report itself. Okay, the text report. Average tune report. Okay. And average tune report. That was the test. All right. So now we populate. I think I can inline that. Unfortunately, Xcode does not inline. Okay. But we said get a scale degree, populate it with the tunes, generate the report. Probably input.tunes. Oh, generate the report. Right now it just writes the metadata, and we want to go from there. All right. This should still pass. Okay, so from here, we basically need to walk through that table. That's kind of why I put off the scale degree fancy version, because it's kind of what we're doing here. We're going to walk through each row, put out the entries in the table horizontally across, and that'll do it. It's kind of, it's kind of awkward, but I think we can. I mean, again, it's this triple loop of stuff, but we'll get there. All right, we're due for a break, so let's take 3 minutes, maybe 4, and we'll come back and start that report going. All right, see you in a few. All right, welcome back. Okay, so our report. Let's run another test. Test tune with some notes. Okay. average tune report. And then we need to get a tune. Very much like we did here. We're going to start small though. Okay, let's just create one string. GAB. Yeah, B. All right. Now our report, we output, well, we'll fill this in. Tunes is tunes. Metadata, I think we can just start with nothing. Okay. And then assert equal. Output should be, well, okay. I think we're going to have 4. Okay. What does it look like? Well, scale degree rows kind of tells us some of it. Basically, I want to say if, well, do I really need all those? I don't know. I kind of want to say if this row is empty, there's no reason to show it. Okay, so let's go back to our test. Let's make it GGGG. All right, so our count is 4. And that is phase 1. Okay, so we have a header row on top, and then we have, I guess this is 2 spaces, so let's say 1. And then, I don't know, maybe this should be a colon. Or maybe this should be 1 space. Colon, space. Oh yeah, Xcode trims off lines on you. It's really annoying. All right, and then this is measure 3 space measure 1 note measure space 1 dot 1 space there's only 4 measures in use. Okay, and these are all 1s. I think we'll put them like this. Let's compare that back to this. I don't know what this column is, but we'll just show the ones that count. So it'll just be this 1. And these columns, 1 for each note. Okay. Generating this is quite enough. This should fail. All right. It's just going to have some metadata. And, I mean, there's nothing in the metadata, so it's a blank line. I guess we'll need a blank line in front. Okay. But we haven't done that. Okay, so now the report. Well, So we're table contents. Okay, we're ready to compute that, I guess. All right, so we need to go through every index in our table. Okay. All right. So for scale, degree, index in, I guess it's 0 dot dot less than scale degree rows dot count. No. Yes. No. Scale degree rows, so that's the row headers. Yes, we need that. Okay. Right. So we're going to run through those. Let scale degree equal. Let's get rows here. Okay, well, it was rows dot index to degree. Okay, so we're going to run through every possible row. And then if, I want to ask the table if it's, well, let's just get something out there and then we can trim it down. Okay, so I'm going to go from measure number in 1 dot 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 table dot highest measure. Oh man, I'm messing myself up with this 0, 1 thing, aren't I? Because I gotta do a -1 here. It's like so annoying. All right, and then within there, we're going to do for note number in 1 dot 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 table dot highest note number. Okay. So now we can get to the table values. Okay. That gets us to goodness. All right. Well, we can certainly get count equals table sub scale degree measure number -1 note number -1. Okay. Table contents. And I think, can I do that to a string? Content contents dot append. Append count. Okay, we're going to have to figure out formatting and spacing and stuff, but table contents should be a var. Okay. Now, this will give us more than we want, but we also want to get in here table dot column headers. Well, dot column headers map to, I guess it's just joined. With space between them. 2 spaces between them. Okay. All right. Immutable value functional. Okay. Okay, so I think I have all the information I want to get in there now, but it's too much. So let's see what we get. We should get a giant report that shows the right number of columns, but the rows are going to be all over the place. Oh, interesting. No spaces there either, huh? Okay. Well, I guess, yeah, we need to do more. Okay. Account. Let's put a space in there. Okay, so what do we need to do? Okay, so the measure number, we don't have to do anything. Scale degree, when we change scale degrees, we want to print we need to print our scale degree. So that's got to be rows dot headers subscale degree index. Okay. And we put this after it. Okay. Yeah, no. Okay, and then at the end, after we've done all the measures, we need to append a new line. Okay. And I'm expecting 23 rows, and I don't want but one. All right. Let's run the test again. Okay, I mean that's looking kind of good. We need to line things up better, but that's more or less the report in real life. Maybe I should put the spaces in the header itself. Would that help? I expect there's a test out there that cares about these, but we'll get it later. We'll just see who all fails. Certainly this report test will fail. Oh. Highest measure. It'd be 0, I guess. Why would that happen? Oh, which test is this? It's this one. Oh, yeah. Okay. Is that? Well, it's a fatal, so we don't know the rest. Let's. I guess if table dot highest measure equals 0 or table dot highest note number is 0, then we're going to return an empty string. Look like that's what we did. Okay, 4 failures. Somebody out here is looking at the table header name contents. Yeah. Kind of a weird test in a way. Okay, we'll deal with those. I'm more worried about these. But it has no columns. What did we get? Empty. Oh, we still need to do metadata. Okay. Good. It's progress. All right. So problem 1. I don't think I worry about the spacing here. It's probably let's see what we got. We need 1, 2, 3, 4 spaces, 5 spaces before the 1.1. All right. And then what we're trying to do here, I really want to say if I want to say something about if table dot empty row, or row is empty, table dot is empty for scale degree. Okay. Let's run this one again. Okay. I mean, that's kind of looking okay. We got to get these things spaced a little better. I really need to figure out the formatting of these, but this is pitch 1, all ones. All right. Yeah, so I want to say if is empty for scale degree, continue. So I'm going to skip to the next. I'm not going to do this entry. Okay. And yeah, that doesn't exist. Okay, scale degree table. All right, let's get his tests. When it's empty. Okay. We can just create an empty table, right? Table equals scale degree table. And assert true. Table dot is empty of scale degree 10. Okay, we could pick anything. Octave. Okay, and this doesn't have a member, right? Degree to index, max. I guess it's kind of like this. Public func is empty. Degree of scale degree. Returns Boolean. Okay. And I guess I want to make sure my test want to test the other way too. Okay. Because, well, okay, we can make this pass. Took a small bite. Okay. This one failed. Scale degree 1. All right, let's make it return true. Okay, that one passes. Let's make the next one. Okay, we'll do something like this. We'll just create something. Actually, I think that's probably about the minimal. This is note 1 in octave 0. 0 is empty. Okay, good. Let's run that. Okay, and right. It should have been empty, but it wasn't, and that's because we're always returning true. All right. So what will be the case is if there's nothing there, then we add stuff in on demand. But if there's nothing there ever, then we'll never have demand. So if the count is 0, then that means we never added anything to that place. Oh, and I gotta go back to degree to index. Okay. Now I think this will be fine. All right, and let's figure out these table things, header names. What I really need to do, I need to make it the reports problem, not the headers. So let's see how this is doing, but it should be doing better. Hey, yeah. Okay, it's our spacing is the issue. But that's all right. I mean, that's quite an improvement. Okay, so I want to get this thing green. It's 2, 3, 4 spaces before the count. I mean, we're doing with such small numbers that I think we can. Okay, 1, 2, 3, 4. Get it green, and then we'll fix that stuff. Okay, still 3. One 1.1 5 1 2 3 4. I don't know. Let's copy this in some other editor where we can look at it with a normal font. Sorry, with a like a Courier or something. Okay. Since these spaces are critical. Okay, so that looks like one too many in front. Okay, so let's go back here. Take this one off. And run that again. Oh. Looks darn close. I don't see. Oh, there's a new line at the end. Okay, well, we could certainly add that to our expectation. Whether this does it or not, I'm not quite sure. Okay. 1.1. Two failures. Okay, that's these header things. Empty table knows its headers. Okay, I think, how about just table already knows its row headers? Table knows its row headers. Okay. And the problem is scale degree table rows has these in it. The problem is what I want is I really want these to be right justified into two spaces. And I don't think it's this thing's job to know that. So let's take these back out. There's an old story of Oscar Wilde, the poet, and talking about how he worked so hard. And he put a comment in the morning and spent all afternoon taking it out. You know, I feel like I'm doing that sometimes here. All right, so these two tests should pass and our report should fail now. Come on. Okay, and that should be our report. And it's going to fail because there's no space in front of the 1. Yeah. Okay. What I think I want to do is I want to say this is right justified into two spaces. And this is right justified into, I don't know, 1.1. Okay. Well, let's get the header right first. Okay. So I'm going to make a function func. I don't know. Is this too cryptic? Right justify string into number of spaces returns a string. Okay. And if I call it on table column headers, no, on row header scale degree, right justify that into two spaces. That should fail. Well, should fail for the right reason. Okay, same way. It has no space in front of our first line. Okay, but if I right justify that, well, I want to do string space. Is it repeating? Repeating space count is something plus string. The count is how many spaces do we need? Well, it's number of spaces minus string.count. Am I doing that right? If the string has 0 characters, it should put number 5 spaces, say. If the string has 3 and we want 5, 5 minus 3 is 2. Yes, I think that's okay. And I guess it's probably slightly, well, let's do this. int string space is needed. It's an int. Equals, well, theoretically, I should be able to extract variable on that. Huh. Okay. Space is needed. Okay. And then in here, I can space is needed equals that. Well, maybe we can pull this out too. Nope. Okay. Now it should pass. Okay. Let's check it in. Add report for average tune. Okay, now I think we still have some work to do. All right, so I think, well, let's run it. We deserve it. I want to see something coming out on this 39 song file. Okay, we'll do the melody average. Okay, yeah, there you can see the spacing gets off, but oh, weird. Somebody, why? Seems there is long versions out there, but I'm not seeing any values. Ooh, what's going on there? Oh, once we got multiple digits, we're getting off on our thing. But why is that row? Why is that row showing when it's all zeros, as far as I can see? Okay, let's do something else. Let's do a quantize in there. 1 4. That's got to help. Okay. There's a value there. Oop, there is one out there. Okay. Wow. Who knew? Okay. How about these? 7 minus 7 6 5 4 3 2 1. Okay. I mean, the weird thing is, ugh. Okay. Well, okay. Two things. One is we still have a spacing issue, but not on our first column. Okay. We definitely have one in our counts and in our other columns. All right. So I think that's what we got to fix today. The other one is let's quantize this to 1 1 so it's a little more approachable. Okay. And I think there were 48 measures in the longest one. Okay. Now, really, what I've done is I'm skipping anything that's not showing up. So that's going to be a little weird. If there's no 5, you're going to be kind of thrown off. Hmm. Maybe we have to track whether we've seen any lines, and we'll put the bottom ones. Wait a minute. It's 5, 4. Okay, so -3, -2, -1 did get chopped off. How do you know the bottom ones, right? I'd have to look at them first. Yeah, so maybe that's an extension. I could say, like, you got to find the first row with contents and the last row with contents, and then show all the ones in the middle. Okay, but I think that was not anticipated. That's out of scope. All right, so write the text report. Okay, um, we've done that. Let's say fix justification on report. Well, let's be more specific. Fixed justification of column headers and fixed justification of counts. Okay. Right. Okay, justification of column headers. Let's see. I guess we need to... Maybe we'll do counts first. No, we should do column headers. Okay. The question is, what's the biggest number in a column header? And I don't know. Maybe it's like 100 measures is really big. Maybe it's 99.99 or something like that. It's definitely not unusual to have multiple. Multiple notes in a measure. You have songs in 12/8, say, and that means they've got 12 notes in their measure if they're eighth notes. So that seems plausible, but maybe... I don't know, the 99, the first 99, the second 99, I'm just picking. Excuse me. 9's a fat number. So if 99 fits, well, actually in Courier font, it doesn't matter, right? It's just any number. So 2 digits is reasonable on the right of that x.y. Do I need 3 on the front? I don't see songs being bigger than 1,000. Okay, so let's allow 3.2. Okay. And I'll just say it this way. And then the counts. Well, I think we could probably say 1,000 or maybe 10,000. Okay, well, 1,000 songs of variations, the same thing. I don't know that I've ever heard of that happening. But let's put in 10,000. 9999, 4 digits. Okay, and then to line them up, I would say this has 6, this has 5. We could probably line up on the second or the first of these 2 digits. Okay, so let's put a space. Okay. Good. All right. So justification of column headers. Let's force that. Let's do 10 measures. All right, and this is 3, 4, 5, 6, 7, 8, 9, 10. Okay. And I think if I, make them all the same note, at least I'll only have one row. Okay, so this is 1, and this should be, I don't want to draw 40 things out here. Let's put 1 in each. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's okay, so 1.1, 2.1, 3.1, 4.1, 5.1, 6.1, 8.1, 1, 10.1. Excuse me. This one should be smaller. All right, and this is what we do now, and I think that's what we want to change. All right, so I think actually we probably put 2 spaces now, so this will be a slight change. Okay, so 10.1 we say should be 1 space. They've got it in 2. So our current thing is we're assuming it's a distance of 3, but I think I'm thinking maybe 99. I'm thinking going the smaller side here. 99 measures. If you have more, it'll kind of fall apart. 1,000 tunes. Okay, let's do that way. So that's 5. And I guess we're going to write justify it. Okay, so let's make sure we got 5 spaces for each of these in our test. Okay, so 3, I guess 1 space between. No, 5 spaces. 1, 2, 3, 4, 5 space. So these should be 3. Okay, except for that one is smaller. And then these should adjust. Okay, so this is 5 spaces. All right, this should fail. Okay. All spacing issues, good. Okay, so our report, scale degree, okay, row header, scale degree next. That's the one. But where's our contents? Right, we want to take table column headers. Let's manipulate them. I guess maybe column headers just to be real clear. Okay, we want to join, well, I think what we want to do is we'll take the column headers, we're going to map each one into right justify that item into 5 spaces. And maybe join separator. Okay, let's separate them by 1 under the circumstances. Okay. Dot map. Okay, so we take the column headers, we map each one into a 5-space thing. We'll put them out separated by a line and then append that. Okay, let's see how that looks. It's going to make the other test fail, but let's focus on the one first. 2 failures, good. Okay, and this one, it's easier to see in here, isn't it? I should just run the one test. Let's do that. Probably faster than me scrolling to it. Okay, so we got 1.1. 1, 2, 3. 1, 2, 1, 2, 3. That's good. Okay. I think this stuff on the front is too much. All right, and I think we want to. Okay. Right. I think it should be 1 space. It should be 3 spaces here. Okay, so let's see what our report's doing there. Okay, so it separates them with a space and then their justified space. That's good. But the front of it should be 3, 4. Okay, 1, 2 for the rest of its stuff. Then I think it should be 1 and then 3, so 4 spaces. Okay, let's try that. And I don't know, I hate kind of twiddling on these spaces, but I think that's probably the right thing to do. Okay, so here, 1, 2, 3, 4. And then this should be 2. I think that might be better. So 3 spaces to cover the row header. 1 space for a separator, and then 2 spaces for the possibility of a 5-digit thing. Okay. All right, and it's looking better. First row is looking good. Okay, now the counts. I guess I want them in that same space. All right, so that's 5 digits, and we'll right justify it, and I think that'll be fine. Okay, so line that up, I guess, one more here. All right, that's what we would like. Oops. Okay, the result does not have that, but we can do it. Okay, that's the report. And where's our count? Okay, right. That should be one space. Well, I guess we can do this. Let's write justify count with where's that 5? Yeah. Let's say let column width equal 5. All right. Okay, and down here in the count, all right, justify count, column width. And we want an extra space between them. Well, okay. Oh, once again, I ran them all. Let's go back. We can find that. Oh, 10 measures passed. Okay, now we need to adjust this one. All right, so this is 1, 2, 3, 4. You should have an extra space. 1, 2, 3, space, space. And these should line up. Okay. All right. And that's everybody. Okay, so add right justifications, so columns and headers line up. All right, and let's give it a run. I think that's really green, yep. Okay, we'll open the file, ABC. I'll add a quantizer, 1/4. Let's do 1 note per measure, and we want this one. Okay. Hey, now that's looking good. I mean, it's a little. I might be happier if they were lined up on the dot, but I think that'll be most likely if it got over 100. Well, we're saying it won't. 3 digits on the dot. Let's make that happen. I think if we right justify this with 4. It's 1. And then append a space after it. It wouldn't look as good for the ones that had multiple, like 12 notes in a measure. But I don't think you'd do the analysis that way anyway. I think you'd probably restrict it to like by a quarter notes or something. All right. Let's see how this looks, and then we'll decide if we should adjust the test to that or not. Quantize by, well, a quarter for starters, sure. Okay. I think that's our winner. Okay, but probably quantize by 1. Run that. I think we are good. All right. The only thing is I would like to put a little message in here that says quantizer recommended. Just as a reminder, it's not much, but I think that would help. Let's see, file input. I don't know if we do that in any reports so far. Whoops, we had test failing because I adjusted the spacing. Okay, so in this one, yeah, we cut out a space in front there. And in this one, we probably do the same. Yeah. Well, what do I know? Is there a space at the end of the line? Sure enough. I can live with that. Goodness. It's one note. Oh, thank you, Xcode. I didn't put that space there because I didn't want it. Oh. Oh. How do I get that there? There must be a setting for this. General. Text editing, huh? Line numbers, good. Wrap lines. No, that's nothing. Editing, okay. Automatically trim white space. Okay. I don't think I leave blanks where I don't want them that often, and things like this I do want. Okay, adjust spacing. Okay. Now, the next thing I wanted to do then, I just want to put that little message in, just like this thing does when it opens the file. It's got that little optional message there. I'd like to do that in our reports. They don't normally do that. So it's going to affect several reports, but we can let the message be blank for them. All right, so let's look at file input view. And I may go a few minutes longer. I'm off next week, so this will be it for this year. And next year, I'm going to start in on some unit testing stuff, just designing a test framework and see how that goes. I've got some ideas I want to try out. All right, so button selected. Yeah, so we have this. And let's add that to report view. That should probably be sync view previews then, shouldn't it? Oops. Okay. Where's our run button? Run. When's button? Center is an inner, which is a view. Okay. All right, so let's make this a vertical stack. With the button. And this text. Let's call it message. And message count. Okay. And we will not show any intro text for that. Okay, so message. Well, let's make that stage.message. And then we'll open sync. Swift. Sync. Protocol. Let's give it a message. Okay, should have 3 places that don't know it. Well, those don't count. Average tune stage does not conform because it doesn't have a message. Quantizer is recommended. That's not really a var. Okay. Parson stage needs a message. And statistics stage. Okay, so this has no message. This one says quantizer is recommended. All right. Uh-oh. There we All right, quantizer, that had no message. Maybe it should be quantized transformation. Find quantizer is. Okay. And we'll run. Ideally, I would turn that off if you actually selected it, but I'm not going to. All right, run. What's going on? I've messed something up. Okay, well, I'll tell you what. Let's see, what would that be? Be average tune stage. No, the stage is okay. It's the sync view, I guess. I guess I'm wondering if this is messed up too. It is. Okay. I've got some dependency on how that button gets passed in, I guess. So I will revert this change. Discard those changes. I don't. Oops, there's one. And make sure everything's working again. Or still. Okay, great. All right, so this is where we are. So we've got those three. Well, we've got two input styles, manual or file. We've got a transformation quantizer. I've got more ideas for others, but I don't have them yet. We've got these three reports. Maybe I would just call that statistics, but whatever. Okay. And the core thing, this parsons code we did, that's all great. Okay, we can compare those tunes. Now we can also kind of get their average. And we can see we would like to put stars on the mode for any given column. So 5 is the most common, 4, 3, 2, deck the halls with, that's this song. This one, wow, it doesn't have a lot of variation. Interesting. Okay. So yeah, these don't. You can see the mode. Oh no, there's a 2 there. So I was going to say the mode might not change. I don't know. This seems a little weird. 1.10, 1.11. There's some very long measures in there. Oh, we didn't quantize. Okay. But the mode is popping out here, and there is some variation, so that's interesting. So I'm happy with this, even if it is just text. I want it to be more visual, but that's okay. All right. Well, thanks for joining. Next time will be whatever the first Monday in the new year is. It's 1 to 3:30 p.m. Eastern Time or 6 to 8:30 p.m. UTC. And like I said, we're going to try out some ideas I have for unit test packages or libraries and see what we can do. I've been looking at Result Builder in Swift, which sort of gives us a DSL kind of capability, and curious if that will work out for it. So thanks for joining today. Hope I catch you in the future. Have a good holiday week. Bye-bye.